Here we're integrating y squared times the quantity of 4 minus y cubed. That quantity is to the 2/3 power dy. See what you can do with this. Find the integral and come back when you're done. So my u is the inside function in the composition. So u is equal to 4 minus y cubed. Du is then negative 3y squared dy. Don't forget there's a negative in front of y cubed, right? So I need to multiply and divide by negative 3. Now I did this substitution basically in my head. Negative 3y squared dy gets replaced by du. So let me do this off on the side. And then 4 minus y cubed to the 2/3 gets replaced by u to the 2/3. And then of course we had the negative 1/3. And so what I'm actually integrating out of all of this mess is really like the function to the 2/3 power. And so I'm really just using the power rule. The power rule for u to the 2/3 is going to give me a u to the 5/3. And so I've added 1 to the exponent. Now I'm going to divide by the new exponent. So I pull a 3/5, or I write down 3/5 as a factor out front. And then we have our negative 1/3 was already sitting there, and plus our constant of integration. And then u gets replaced by 4 minus y cubed. So I did this basically in my head. I would encourage you to work on trying to be able to do that. It's always okay to write it down in terms of u and then bring it back in terms of the original variable. But if you can, it's kind of seeing the trees in the forest, right? If you can recognize what is making your du and then recognize, oh, I'm integrating the 2/3 power, then I add 1 to that exponent, divide by the new exponent. I don't have the answer written down here yet. The 3's will divide out, and I have negative 1/5, and then 4 minus y cubed to the 5/3 power plus c is going to finish that off. All right, next up, the integral of the sine of the square root of x over the square root of x dx. I see that we have a composition, and the inside function is the square root of x. So with that in mind, I'd like for you to tackle this and come back when you're done. The inside function u is equal to the square root of x, and so du is 1 over 2 times the square root of x dx. Which means I really need a 2 down here in the square root of x. So the square root of x in the denominator can throw us off a bit until we realize that that is actually related to a du. And I separated that square root of x in the denominator out as its own fraction, 1 over square root of x. But we need a 2 here. And so I've divided inside and multiplied outside by 2. All right, I'm just doing whatever I need to do to fix the integrand. Now, that 1 over 2 root x dx is the du. What I'm actually integrating is the sine function. And the integral of the sine function is negative cosine. The 2 comes along as a coefficient. So I have negative 2 times the cosine of the square root of x plus c. All right, now we've got one that's, again, a bit different. We're looking at the integral of dt over the cosine squared of t times the square root of 1 plus the tangent of t. It's kind of hard to see where the composition is. I mean, 1 over cosine squared of t is essentially its own composition, but with practice you start to recognize. In this case, it's going to be the inside of the radical. That's often the case, by the way. So I'm going to say u is equal to 1 plus the tangent of t, which means that du is equal to 0 plus the secant squared of t dt. That's the same as 1 over the cosine squared of t dt. So if I rewrite this integral, I can rewrite it as 1 plus the tangent of t to the negative 1/2 power times the secant squared of t dt. And all I'm doing is I'm writing in the denominator cosine squared of t as a factor of secant squared of t. What I'm actually integrating is this base, 1 plus tangent of t, to the negative 1/2 power. To integrate to the negative 1/2 power, 1 plus the tangent of t will now become, it'll now be to the 1/2 power, right? And then divide by the new exponent. So I multiply by 2. And then the question is like, where does the secant squared of t go? Well, that's my du. And so it gets kind of eaten up in the integral. My answer is, well, I'm going to write it the way it was given. 2 times the square root of 1 plus the tangent of t plus c. And this is one where I do, again, encourage you to differentiate to check the result. And then that'll answer the question of like, where did the secant squared of t go?